All right, folks, you have had a couple of days now to get used to the idea of a function. And so, starting us out this morning, I just want to remind you of some of the vocabulary that we've been dealing with. Okay, so here's what we've learned. We've learned that a function has a job to do. The job of a function is to take an x and to connect that x to a y. So that is a function's job, is to connect an x to a y. And we know that what that creates are ordered pairs. Ordered pairs. So that is a function's job, is to create ordered pairs where x's are connected to y's. Now, we learned that an x value goes by a couple of other names. An x value is called an input because it is what we put into the function. It is also called domain. So x values, input or domain. And then likewise, we learned that this y value is called the output. So that's what the function gives us back when we put x in, and it also goes by the name of range. And then one last pretty important thing that we've talked about is that for a function, there is a limitation. And that limitation is that in a function we can have no repeating x values. No repeating x values. All of the x values in a function have to be different. If they are not different, then it is not a function. So this is the beginning. This is what we've been working with for the last couple of days. And now what we want to do today is kind of take the next step with this. So today we are going to be looking at equations as functions. Equations as functions. Now, I want to remind you as we get started on this that an equation is something we have worked with already, and we know that an equation has an equal sign, always. Okay, so what we're going to look at is how an equation can act as a function, how an equation can connect an x value to a y value. And what you're going to see today is that when we start talking about an equation as a function, is the equation is going to describe to us how those connections are being made. All right, so here's what you need to know. Any function can be represented by an equation or rule. So any function that we talk about can be represented by an equation or a rule. Now, it's the job of that rule so the equation or rule describes how x is connected to y. So that's kind of an important thing here. The equation or rule that you're working with is going to describe how x is connected to y by that particular function. So, with that said, let me give you an example. So what I have here is actually a function rule. Okay? And I want you to look at what this rule says, okay? I want you to notice that this equation, this function rule, starts out by saying y equals. Y equals. Now that y there that we're looking at, we know is the output. Is the output. So this equation is saying that the output is equal to what we see over here. Now on this other side, what I want you to notice is we see this. We see x plus 2. X plus 2. And we know that that x that we're looking at right there is the input. So remember what I said a second ago. I said that these equations, these function rules, are going to tell you how x is connected to y. So what this function rule says is that the output is equal to whatever the input is plus 2. So this equation is telling me exactly what this function is going to do to that x. It's going to add 2 to it in order to find the y. All right, so let's look at how this works. To look at how this works, what we are going to do is we are going to make something called a function table. A function table, and you've done this before. All right, in a function table, what I'll do is I'll make 2 columns. You'll notice this column on the left is being labeled as x, and then the column on the right is being labeled as y. So here's where I'm going to put my input, and here's where I'm going to put my output. All right, now, what I need to do is pick some x values, and I can actually control that. I can actually make some decisions about what I want x to be. So I think I'm going to first of all let x be -2, and then I think I'll do 0 for x, and then I think I'll do 1 for x, and then I think I'll do 2. So I've chosen 4 x values. I could choose more if I wanted to, and I can choose anything that I want for x, but these are the 4 numbers that I think I'll use. Now, what I'm going to do here is I'm going to use this rule to figure out what y value needs to be connected with each of those x's. So think about what we're going to do here. X is my input. So I want to input -2 up here where I see x. So I'm actually going to take this x value and put it into the function. So if I do that, that would make this y equals a -2 plus 2. And then notice that that's something I can work out. -2 plus 2 I know is 0. So if I input -2 for x, then I'm going to get an output of 0 for y. So this function connects -2 with 0. Those two belong together. And now what I'll do is just continue doing the same thing. So next I'll input a 0 where this x is. So that'll make this y equals 0 plus 2. When I do what this says, 0 plus 2, I get 2 as my answer. So y is equal to 2. So 0 is connected to 2. So notice how this equation is connecting the x that I put in with a y value that it puts out. All right, so next I'll input 1 for this x. So that'll make this y equals 1 plus 2. 1 plus 2 is 3, so 1 connects with 3. And then finally, input 2 for x. That'll give you y equals 2 plus 2, which is 4. So 2 is connected to 4. And you know, notice it's just basic math here. I input the x, I plug in the number for x, and then the function tells me what the y value should be. Now when you look at this table, what I want you to realize here is that when we have negative 2 connected with 0, what we actually have is an ordered pair. We've just made an ordered pair. When we connect 0 with 2, there's another ordered pair. 1 with 3, and then 2 with 4. And once we recognize that we have just made a table filled with ordered pairs, the next step that we could take with this is we could actually graph this thing. So let me get some graph paper. All right, and what I'll do is I'll start by making an x-axis. We reviewed graphing the other day. And then I will make a y-axis. Whoops, that's a little crooked. And then we'll go through and we'll graph each one of these ordered pairs. So for negative 2, 0, I'm going to go to negative 2 on the x-axis and 0 on the y-axis. So starting from the origin, if I move negative 2 on x, then that means I'll go to the left 2. And then 0 on the y-axis means that I will stay there. So right there is negative 2, 0. All right, for 0, 2, I'll go to 0 on x and then 2 on y. So starting at the origin, I will stay put. That's the 0 part of this. And then on the y-axis, positive 2, I'll go up 2 for that. So there's 0, 2. For 1, 3, we'll go positive 1 on x, which is right 1, and then positive 3 on y, which is up 3. So there's 1, 3. And then we'll finish off with 2, 4. So positive 2 on x, that's right 2, and positive 4 on y is up 4. Now, when you look at those points after I graph them, what I want you to notice is there's a pattern to this. I want you to notice that these points are making a nice, neat, straight line. So what I could do now is actually take my pencil and connect those dots. And you know, like I said before, I chose to use these 4 x values. I could have used others as well. And what I want to point out here is that if I take this straight line that I've drawn and I were to pick another point, say right here, let's figure out that ordered pair. All right, on the x-axis, I would have to go in the positive direction. And I would go 1, 2, 3, 4, 5. So I've gone to the right 5, that would be positive 5. And on the y-axis, I go up 1, 2, 3, 4, 5, 6, 7. So 5, 7 would be that ordered pair. So notice that has an input of 5 connected to an output of 7. Well, if I use my function rule, which was y equals x plus 2, the y is 7, the x is 5, so that says that 7 is equal to 5 plus 2. Well, what is 5 plus 2? 5 plus 2 is 7. 7 is equal to 7. So notice that that ordered pair fits what this function rule says it's going to do. If I were to move over here and pick this point next, okay, on the x-axis I would move in the negative direction, so left 1, 2, 3, 4, 5. So that would be negative 5 for x. And then I'm moving down on the y-axis, so that would be down 1, 2, 3. Again, if I were to take my function equation, y equals x plus 2, and plug in, look what would happen. The y value now is 3, or excuse me, negative 3, because I went down 3. And that would equal the x value, which is negative 5 plus 2. Well, if I do negative 5 plus 2, I definitely get negative 3. So in this particular function, the y value is always whatever the x value is plus 2. So notice, this is just a simple little exercise of plugging the x in, putting the number they give you in for x, and then working it out and getting that y value, making those connections. All right, let's try another one. This time, let's do y equals 2x plus 1. So that is my function rule. The output y is equal to 2 times whatever the input is plus 1. So this over here, this is the actual rule that tells you how this function makes its connections. It does 2 times whatever x is and adds 1, and that's how it makes its connections. All right, so table time. And let's maybe do -3 for x. On today's assignment, I actually chose your x values for you. But, you know, if it were left up to you, you could pick. I'm going to use 0. I'm going to use 1. And I think I'll use 2 again. So we'll do -3, 0, 1, and 2. So keep in mind that these numbers over here are my inputs. This is what I want to put in. And then the numbers that I'll get over here are my outputs. That's what the function is going to connect to. All right, so notice, the first thing that I want to input for x is a -3. So right here where this x is, I'm going to put -3. So that gives me y equals 2 times a -3 plus 1. Just plugging it in. Now I need to work this out. So first I'll do 2 times -3, which is -6. And then -6 plus 1 is -5. So when I input -3 for x, that is going to connect to an output of -5. You put the x in and work it out. All right, so next we'll input 0 for this x. So that'll make this y equals 2 times 0 plus 1. So let's do what it says. First it says to do 2 times 0, which is 0. Then add the 1. 0 plus 1 is 1. So when the input is 0, it connects to an output of 1. We're going to input 1 for x, so that'll be y equals 2 times 1 plus 1. So first it says to do 2 times 1, which is 2. And then we add 2 plus 1 and get an output of 3. So when x is 1, the output is 3. And then we'll finish up with one more. We're going to input 2 for x, so that's going to be y equals 2 times 2 plus 1. So we'll do 2 times 2 is 4, and then 4 plus 1 is 5. So notice, to fill in that table, we just input each number for the x and do what that function equation says. We work it out, and that tells us what y value will connect. All right, now again here, this table gives me some ordered pairs. So I'm going to go ahead and take a minute to graph this. X-axis. Y-axis. First ordered pair is -3, -5. So on the x-axis we're moving left 3, and on the y-axis we're moving down 5. Yeah, I counted that right. Okay, second ordered pair is 0, 1. So on the x-axis we're not moving, but then on the y-axis we're going up 1 in the positive direction. 1, 3. On the x-axis, we're moving positive 1, so right 1, and on the y-axis, up 3. And then finally, 2, 5. So on the x-axis, we're going right 2, y-axis, up 5. And you can see again here, nice pretty straight line. Now, real quickly, let me say this. Not all function equations will give you straight lines. We are doing straight lines right now, because they are the easiest. So don't get the impression from this that all function rules will be straight lines. They won't. But for right now, they will be, just because that's the easiest to work with. These functions that I am doing with you here today are called linear functions. And they're called linear functions because the graph is a line, because they make straight lines. And you know, that's something we'll deal with more later. All right, so notice again, function rule tells you do 2 times whatever x is and add 1. So it tells you what to do. All you have to do is input those x values and do what it says. And that will show you how x's and y's are connected. All right, I want to do one last problem with you. And this one is going to look a little different. So this problem is going to say, find the range of y equals 3x plus 5 if the domain is -3, 0, 2, and 5. Now, when you look at that at first, you may think, what? You know, what is that asking me to do? But what I'm going to show you is that this is really just about knowing your vocabulary, okay? Now, the first thing I want you to notice is that right here, we see what we've seen in those other 2 examples. We see right here our function equation. And notice what he says that he will do. To get your y value, he will do 3 times whatever x is and add 5. So that's how he operates. He does 3 times x and adds 5. Now, I want you to look at what they asked you to find. The first part of this question says find the range. Range is a word that we should know. Range refers to y values. So notice what they're saying to you here. We want you to find y. We want you to find y. Now, coming down here to the bottom part, here comes this last part. It says if the domain is -3, 0, 2, and 5. Now again here, domain is a word that we should be familiar with. Domain is x values. So when they say the domain is -3, 0, 2, and 5, what they're saying is x is -3, 0, 2, and 5. So even though this problem looks different, it's not really. They still want me to make a function table. They still want me to make a function table. And in a function table, I know I need numbers to put over here for x. Well, they've given them to me. They said the domain is, the x's are -3, 0, 2, and 5. So they're telling me they want me to put -3 as an x, 0 as an x, 2 as an x, and 5 as an x. So domain is x. They have given me the numbers to put in for x. And then they said find the range, find the y value, so they want me to fill in this column. So this is really the same question that we just did in those other 2 examples. It's just written in a different way. They want me to find the y's, which is what I've been doing every single time, if I know the x's are these numbers. So this is just going to be input, output. So first we're going to input -3 for this x. So that will make this y equals 3 times -3 plus 5. And I'll do what this says and work it out. So first I'll do 3 times -3. I know that's -9. So I get y equals negative 9 plus 5. And then I'll do negative 9 plus 5 and get negative 4. So my output for negative 3 is negative 4. All right, next I'll input 0 for the x. So that'll make this y equals 3 times 0 plus 5. And I'll do what this says. So first I'll do 3 times 0, which is 0, which means then I'll have to do 0 plus 5, and my output for 0 is a 5. So notice those connections being made. All right, next up, 2 will be input for x. So y equals 3 times 2 plus 5. First we'll do 3 times 2 and get 6. Then we'll do 6 plus 5 and get 11. So 2 connects to 11. And then we'll finish off by plugging in 5 for x. So 3 times 5 plus 5. First we'll do 3 times 5 and get 15. And then 15 plus 5 is 20. Now notice on this one I don't have to graph, but I do need to answer the question. They said to me, find the range so right here I'm going to answer their question. The range on this problem is negative 4, 5, 11, and 20. Those are my y values. So to kind of recap what we've talked about here today, when they give you an equation will act as a function. You will input an x value, so you'll put a number in place of the x, and then you'll do what it says, and that will give you that output or that y value. So equations make these connections. You give it x, it will connect it to a y. Your assignment today is going to be much like these examples that we've done here, where you are just going to be plugging in numbers for x and working things out. Use your calculator to help with working it out so that you avoid sign mistakes and just little silly mistakes. And certainly, if you have questions, let me know, because we are going to be building on this. So this is just another block as we build. So any questions, be sure and let me know.